and whatever we are doing over here, that will get recorded. Okay, I'll just do a few part of this so that you will understand that next time if you are doing any difficult topic that you are finding, okay, we will be able to record the entire session so that whenever you want the session to be reviewed again, okay, I'll just send you the link. You can see all the things
Yeah.
again. All right.
Okay.
Yes. Now we are coming to the basic structure of an atom as you have stated earlier. The atom is consisting of three basic particles or fundamental particles. One is protons, which are going to be positively charged.
Electron.
Second one is electrons, which are going to be the negatively charged particles. And finally, last one, the neutrons, which are going to be uncharged particles. Okay. How basic structure of an atom is? Okay.
Nucleus.
Centrally placed nucleus is there. Inside this nucleus, which particles are present?
Protons and neutrons.
Okay, protons and neutrons. Obviously, these both will add together, and that's going to give you the atomic mass number. And where will the electrons come?
Outside.
Okay, they will be
On the
placed in,
orbit.
right? They will be placed in
Two.
different orbits. Okay, depending upon how many protons are there, that many number of electrons will be present in a neutral atom. So this is the basic structure of an atom. We have considered these basic definitions. I'm just going to take up the next definition. What is electronic configuration?
Electronic configuration um is the structure of the atom in which there are orbits and electrons in the atom. How
No,
many
this,
electrons there are in the
no, this is
atom?
not very precise. In precise words, if you say electronic configuration is simply the distribution of electrons in different orbits.
Yeah.
Now, can you place any number of electrons in any orbits? Any of the orbits?
No.
There are certain rules or principles that are supposed to be followed in order to place all these electrons in different orbits. Okay. Can you tell me, in a particular orbit, there is a particular formula to calculate that how many electrons can be placed in the first orbit, in the second orbit, in the third orbit, in the fourth orbit, and finally, how many maximum number of electrons are there that can be placed in the last or the outermost orbit? Do you have the idea of these?
I have yeah. In the first one there can be only two electrons
How
present.
did you get that?
Uh, we didn't have a formula for that. It was just
Okay,
told to us.
all right, and in the second orbit,
Eight.
all right, in the third orbit,
Eight.
no. There is a particular formula, okay, afterwards you will learn uh, the formula that relates with the maximum number of electrons that can be placed in a particular orbit. The formula is going to be 2n square, where this n stands for the number of orbits. Now for the first orbit, the value of n is going to be 1. So this is going to become 2 multiplied by 1 square. Okay,
Yeah. So two.
1 square is 1 multiplied by 2. So maximum number of electrons that can be placed in the first orbit will be 2.
Two.
Similarly, you can calculate for this. Here for
Yeah.
the second orbit, the value of n is 2. So that is going to become 2 square. The formula is 2n square.
So
So it's
two
going to
into
become
four,
2
which
into
is
2
eight.
square. Okay, so that's going to become 8. Similarly, for the third orbit, this is going to become 2 multiplied by
Three.
3 square. So how many maximum electrons you can place
18.
in the third orbit will be 18.
But
Can you
then
tell me?
so
Yeah.
um uh, in usually as they say, we've been taught, I think, that 2, 8, 8, and then if there's something 6 like that we've been taught. So
We'll come to the electronic configurations when we are going to consider the entire periodic table. The periodic table chapter is there, okay, and we will try to work out the electronic configuration of all of these elements. Many of these elements electronic configurations are asked even in past papers, okay. So many of the elements we'll just take up their atomic number and then we will just work their electronic configurations out. Okay, we'll just come to those electronic configurations. Right now we are just doing the basic formula, how many electrons you will be able to place in that particular orbit. Now we are going to come to the fourth orbit. How many electrons, by applying this formula, you will be able to place in the fourth orbit?
32.
Correct. It will be 2 multiplied by 4 square, that is 16 into 2. So 32 electrons maximum can be placed in the fourth orbit. Okay. Now, of course, fifth orbit, sixth orbit, and seventh orbit are also there, but that formula is not applicable because so many elements only are not present. Okay, as you can see here in the periodic table, this periodic table maximum contains about say 110 elements. Of course, these other elements which are placed over here, they have been discovered, but yet the scientists have not been able to ascertain or get their electronic configurations. So we'll just stick to up till the rule up till the fourth orbit. Any orbit cannot have more than 32 electrons. Apart from this, the last or the outermost orbit can have maximum or how many electrons? Maximum how many electrons it can have?
I don't know.
It's 8. Okay,
Just 8.
just 8. If it is a last orbit, it can't have 32 electrons or 18 electrons. If it is a last orbit, then it should always have 8 electrons. This rule that is given, that is known as octet rule. Okay, what is octet rule? The last orbit can have maximum of 8 electrons. Okay, now on the basis of this, we'll just work out some electronic configurations. Okay. All right, we'll start straight away with the first element. Okay, you can see here the first element is placed here in the middle. Okay, if you want, I can zoom in a bit more.
No, it's fine.
Okay, you should be able to see it clearly. That's it. All right, the first element over here is H, that is hydrogen. Okay, so this is going to have one proton. There are no neutrons in the nucleus, and obviously because there is one proton, there is only one electron. Okay, so I'm just going to write PEN, protons, electrons, neutrons. This protons is also equal to the atomic number. All right, do you know the symbol of atomic number?
Symbol of atomic number.
Yes.
No, I don't think so. There's a symbol. You have to just put it up.
Okay, the symbol of atomic number is Z. Okay, in this class you will be doing it. So Z is the symbol of atomic number, which is simply equal to the number of protons. So for hydrogen, the atomic number is 1 because there is one proton, so there is going to be one electron and there are no neutrons. If I'm supposed to draw the structure of hydrogen atom, okay, this is the structure of hydrogen atom. This is the nucleus that I have drawn. Inside this nucleus, there is one proton. Okay, because here there is one proton, there will be one electron. As you can see here, there is only one orbit, and inside that there is only one electron. Therefore, you can tell me its electronic configuration. What will be the electronic configuration of hydrogen?
It'll be 1.
Simply it will be 1 because there is one orbit, there is only one orbit, and inside that there is only one electron. Therefore, its electronic configuration will be 1.
1.
I'm just going to come across another term, that is valency. And one more term I'm going to discuss over here, that is valence electron. These are two more definitions that we are going to discuss today. What is valence electron? You have the idea of this?
I know a little bit about valency.
Okay. Valence electron, the definition is very simple. It is simply the number of electrons in the last shell or last orbit.
Hmm.
Okay. So obviously the first and last orbit is there, which is having only one electron. Therefore, valence electron over here will also be
1.
1. What will be the valency of hydrogen?
1.
It will be 1. What is the meaning of valency?
The number of electrons in the last orbit.
No, that is valence electron. I'm asking the definition of valency. Okay, I'll just give you this definition. Valency is simply the combining capacity
Hmm.
of an element. Have you done exchanging of valencies and writing the formula of a compound?
Exchanging valencies,
Yes,
as in giving from the last orbit to make them full. Yeah, we've done that.
correct. So as per this, okay. Now in the first orbit, as we have done before, how many electrons maximum can be placed
1.
in the orbit? No, maximum.
2.
Correct. First orbit can have maximum 2. One electron is already there. How many more electrons are required to make the orbit full?
1.
One more electron is required. Therefore, its valency is 1.
1. So
Okay.
it's how many electrons are needed to make it full.
Needed. Okay. To make the outermost orbit completely filled up. That is what is known as valency. In other words, it is also known as the combining capacity of an element. This I'm going to explain you with the help of considering different examples. Okay. The second example that I'm going to take, that is of okay, you are going to get all these things after the class is over in your mailbox. The second element that I'm going to consider over here is helium. I'm just going to write protons, electrons, neutrons. There are 2 protons, so there will be 2 electrons, and also, okay, if you see in the periodic table, the atomic mass number is given, that is 4. Therefore, there will be 2 neutrons. I'm first going to draw the structure of helium atom. First, I'm going to draw the nucleus. Okay, this is your helium nucleus. Inside this, there are 2 protons, there are 2 neutrons, and one orbit I'm going to draw. Inside this, there are going to be 2 electrons. Okay, the next part that I'm going to take is valence. First is going to be its electronic configuration, then its valence electrons, and finally its valency. What will be the electronic configuration?
Electronic configuration will be 2.
Okay,
Valence electrons is 2,
okay,
and it's full, so you don't need
okay.
anything.
So its valency will be 0
0.
because its orbits, the orbit in which the electrons are required, that is completely filled up. Therefore, its valency is 0. Okay, because its valency is 0, they have inability to combine with other substances. Therefore, these all
Noble
gases
gas.
are
Noble
known
gas.
as noble gases. There is another word given to these noble gases. Have you come across? These are known as also inert gases.
Okay.
Okay, inert means they cannot react with other substances. That was for atomic number 2. I'm just going to jump to some other elements in order to explain you the definition of valency. The next element that I'm going to consider over here is oxygen. I'm just going to take you to the periodic table. Okay, you can see where oxygen is. Okay, the element oxygen is over here. All right, I'm just going to zoom in a bit more. Okay, this is what you can see. This is oxygen. Now here, what is written at the bottom?
Is the atomic number.
Correct. This is the
That's
atomic number.
Atomic mass.
Right. What is written over here at the top is the atomic mass number.
Mass.
So that is going to be the sum of number of protons and neutrons, and this is going to be only the number of protons and of course number of electrons in a neutral atom. All right. Now coming back to that example, oxygen is having atomic number. Okay, I'm just going to write it like this. The atomic number is 8. Its atomic mass number is 16. I'm going to write proton, electron, neutron for this.
Protons are 8.
Electrons will be 8. Neutrons will be this 16 minus 8. Okay, so that's going to become 8. The next thing that I'm going to come to this part is going to be its electronic configuration. Okay, in the first orbit there will be 2 electrons maximum you can fill. There are 8 electrons as 8 protons are there. Okay, so 6 more electrons that will be placed in the second orbit, therefore 6 electrons. The next part that I'm going to come over here is valence electrons and finally valency. How many valence electrons are there?
6.
Correct. You just have to see the number of electrons in the last orbit, that will be 6. What will be its valency?
Plus 2.
Just don't say at the moment plus or minus. It
Okay,
needs 2 more electrons. Okay, so therefore its valency is going to be 2. Now I'm just going to go to that part of definition of valency. Before that, I'll also draw the atom of oxygen, because in some cases you will be asked to draw these atoms. So this is the first part, that is your nucleus. This is your oxygen atom. Okay, in which there are 8 protons, there are 8 neutrons. Electronic configuration we have written, that's 2 6. So in the first orbit there will be 2 electrons, and in the second orbit there will be 1 2 3 4 5 and 6. As it needs 2 more electrons to make its orbit completely filled, that is 8 electrons, therefore its valency is 2. Okay. Yes, now we have worked out the valency of hydrogen, which was 1. We have worked out valency of oxygen, which was 2. Now in order to write down the formula of the compound that is produced between hydrogen and oxygen, we'll just exchange these valencies and we are going to just write this as a suffix. I'm just going to bring this 2 down over here. I'm just going to bring this 1 down over here. So that is
if you're not written anything, it's automatically assumed as 1.
Yes. Okay. No number is written. It means even if 1 is there, we are not going to write that particular number. So the formula of this compound is going to be H2O.
Why do we need to exchange it?
You see, this is a part of question that you are asking from the other topics that are going to come in this particular year. That is going to be chemical bond. That is going to be chemical bond or chemical bonding. Okay.
I think you've done a little bit of that, but we've never exchanged it.
Okay. I'll also explain you how it can be exchanged, why it is also exchanged. Okay. Now you see, valency of hydrogen is 1. Valency of oxygen is 2. I'm just going to draw both of these atoms. Okay. First, I'm going to draw the oxygen atom. I'm not going to draw the inner orbits, because they are not going to take part in the chemical reaction whenever oxygen and hydrogen or any other, in fact, any other elements combine together. So I'm just going to draw the outermost orbit. So I'm going to draw the valence electrons, that is the number of electrons that are present in the outermost orbit, which are going to be 6. This is your oxygen atom, which is consisting of 6 electrons in its outermost orbit. This is hydrogen atom, which is going to have 1 electron. I'm going to draw another hydrogen atom over here with a single electron. See, when hydrogen and oxygen, all of these elements are going to combine, what's going to happen is this oxygen atom which is there, its orbits will get overlapped like this.
Yeah, we did like that
Correct?
before.
So here this is going to be the electron of hydrogen, single electron original.
They share it.
They are going to share one electron.
Share
It means one oxygen atom is going to share one of its electrons each with 2 different hydrogen atoms, and of course the other electrons which are there, they remain unaffected. Now if you are going to count the number of electrons in an oxygen atom, 6 electrons were there of its own. These other 2 electrons which are there, okay, from where they have come? They have come from hydrogen atom. Okay, so if I'm just counting the number of electrons in the orbit of oxygen atom, 6 electrons of its own and these 2 electrons of hydrogen, that makes 8 electrons. Similarly, hydrogen, if I'm considering this orbit, how many electrons they are becoming for both of these hydrogen atoms?
2.
They are becoming 2 electrons. So the orbit of hydrogen atom also gets completely filled. Okay, so you see how many electrons are required, that is going to decide the combining capacity of an element. Okay, that is what valency is. That is the definition of valency. Now over here, as I have stated over here, okay, you can see over here the valency of oxygen is 2, the valency of hydrogen is 1. Therefore, by exchanging these valencies, we will be able to get the formula of the compound, and in which way they are going to combine together, that is also stated over here.
So does it work with all elements?
Most of the elements. In some cases, some exceptions are also there. And in later chapters, we are going to study what these exceptions are there and why these exceptions are existing. Okay, so that is going to come in the later part of the chapters, that is chemical bond or chemical bonding. Okay, so this is one of the examples of combination of atoms or formation of compound that I have considered by exchanging valencies and also diagrammatically showing how these compounds will be formed. Okay, after the class is over, for the next time, I want you to get the electronic configuration for first 20 elements. I also want you to draw each one of these atoms and keep them ready when I come and check your work. Okay, so this is what your homework is going to be. What I'm going to check next time is the electronic configurations of first 20 elements and even the structure of atom of first 20 elements. Of course, I'm going to mention that to you when I'm going to mail all this stuff to you. I'm going to consider some other examples of valency. Let me take over here. Carbon is there. That's going to combine with oxygen. All right. Now from the periodic table, just tell me what is the atomic number, electronic
6.
configuration. Okay, its atomic number is 6. So what will be its electronic configuration?
2, 4.
Correct. Its electronic configuration is 2, 4. The electronic configuration of
2,
oxygen
6.
is 2, 6. So for carbon and for oxygen, first of all, what will be the valency of carbon?
2.
How
No,
2?
sorry. 4.
Okay. It is having 4 electrons, it has to make 8. So 4 more electrons are required. For oxygen, 2 more electrons are required. Okay, so its valency of oxygen is going to be 2. Now
So
can you?
do they share it?
Yes, obviously. Afterwards, we are going to draw the structure of the compound that is going to be formed between carbon and oxygen, and that we are going to do after we get the formula. Now, from these valencies, what will be the formula of the compound that is formed between carbon and oxygen?
C2O4. No,
That's not
C
right. What are we going to do over here?
CO2.
See, we are supposed to cancel the common factors.
Oh,
This will
right.
be 2 ones are,
And
and this is
2.
going to be 2 twos are. So this 1 will come over here, and this 2 will come over here. So ultimately, the formula that we are going to get for this compound is going to be
CO2.
CO2. Okay. Now, in terms of structure, if I am asked to draw what is the diagrammatic structure of CO2, that is carbon dioxide, this we are supposed to show with the help of electronic configuration. Of course, valence electrons, that is only the outermost electrons. Now, here carbon is there. The number of electrons that are present over here will be 4. Okay, I'm just going to represent this with the help of a cross. This is known as dot cross or cross dot structures, so that we realize that these are electrons of carbon, and the dots are circles which are there, they are electrons of oxygen. Now, as we have said, as we worked out, the formula of carbon dioxide is CO2. It means there are 2 atoms of oxygen. So this is going to be your atom of oxygen. How many electrons are there in the outermost orbit?
There are
6.
going to be 6.
Okay, so 2 electrons I'm going to place over here. The other 2 electrons and the other 2 electrons, of course, they will be placed over here. Okay, this is going to get combined together. Similarly, there is another oxygen atom on the other side. The oxygen atom, outermost orbit, there are 6 electrons, which I'm going to represent like this. All right. Now, when these both elements combine together, that is, these 3 atoms combine together,
2 to
these 2,
share from each.
yes. Okay, so first I'm going to draw the centrally placed carbon atom. One sec. I'm just doing freehand drawing. This is your oxygen atom. The 2 crosses of carbon, the 2 circles are dots of oxygen. Again, here 2 crosses of carbon and 2 circles or dots of oxygen. And the remaining other electrons which are there, they will be unchanged. Now you can count the number of electrons in the last shell for all 3 of these atoms. You can check
8.
out. Okay, 6 electrons were already there, and 2 more electrons
2
that are shared with carbon. So that is going to make 8 electrons in this orbit. Similarly, for same thing applies for the second oxygen atom. For carbon atom, 4 electrons were already there. The other 2 electrons are shared with 2 different atoms of oxygen that make 8 electrons in the outermost orbit. Okay, these kind of a bonding that is taking place, do you recollect what is it known as?
Chemical bonding.
Yeah, obviously it is chemical bond, but even there are 2 different kinds of chemical bond also. Because here, as we have seen over here, I have not mentioned the valency of either carbon or hydrogen as plus or minus. In this case, sharing of electrons is taking place. What is this kind of a chemical bond known as?
Covalent.
Correct, it's known as covalent bond.
Okay. Okay, fine. Yes.
Right, covalent bond will be there when there will be sharing of electrons. Can you tell me what other kind of bond is there?
I don't know.
Can you tell me how other kind of bond can be produced other than sharing of electrons?
By taking and giving.
Right. Okay. Another kind of bond that can be produced will be by transfer of electrons.
Which bond is this?
I'll just tell you that. It means one atom will donate or give electrons,
Yeah. And the
and
other will
another
take.
atom is going to accept or take electrons. Okay, this kind of a bond that is produced is known as,
Ionic.
there is another name also given to this, that is electrovalent bond. But generally we are going to use this term only, ionic bond, which is produced by transfer of electrons, that is give and take of electrons. I'm going to consider here one more example for ionic bond. The most common example that is considered over
Yeah.
here, okay, that is sodium chloride. You can just look into the periodic table to get where sodium is. Yes. Do you want me to zoom in?
No, fine. Sodium is out. Sodium and chlorine, right?
Yeah. Sodium chloride. So sodium and chlorine.
Yeah. Chlorine is here and sodium is here.
Okay.
Sodium has 11
All
atomic
right.
number, chlorine has 17.
Right. Okay. So sodium is Na. Its atomic number is 11. Chlorine is Cl. Its atomic number is 17.
17.
The first thing that we are going to get over here is the electronic configuration of both of these elements.
281.
Okay. This is going to be 281.
This is going to be 287. So
Okay.
to make this full and this full, um, Na gives one electron and Cl takes one electron.
Okay. So one electron will be transferred from Na to Cl. Okay. So your valence electrons will be 1. This will be 7, number of electrons in the outermost shell. And then valency.
-1.
For Na it will be
+1. +1.
+1 because electron is lost, negative charge is lost. And obviously this is going to become -1. Alright, because when one electron is lost, there will be one proton more
Hmm.
than sodium atom.
Hmm.
Okay. Therefore, the valency of sodium will be +1, and here now the valency is going to be -1. I'm going to also represent this with the help of a diagram, okay, for formation of sodium chloride. Let's draw first sodium atom,
Keep
and
it
then we are going to
closer.
draw Cl atom. Okay. So here the configuration is 281. This is 287. I'm just going to draw only the outermost shell or the orbit. Okay. Only one electron in the outermost shell. Cl is there. There are 7 electrons in the outermost shell. When both of these atoms combine, this one electron will get transferred from Na to Cl. Okay. After combination of these atoms, they will be represented like this. Okay. Here Na is there. Alright, that electron will be lost. So I'm not going to show any electron over here. Cl is there. 3, 4, 5, 6, 7, and that one electron has come from sodium. Now these both things will be shown in a box. This is going to become plus. This is going to become
Minus.
minus. This is what is known as chloride ion.
Just chloride. It has to be sodium chloride.
Yeah. And of course, this is sodium ion.
Oh, like that. Separate.
Separately, if I'm considering, this is sodium ion and this is chloride ion. Obviously, they will be combined together, and that is going to be known as sodium chloride. These bonds that are ionic bonds, which are formed by transfer of electrons, are very strong bonds, and they have specifically different properties that are there from covalent substances or covalent compounds. Okay, so this is about formation of sodium chloride. That's an ionic compound. I'm going to give you some examples now, which you are going to work out in your notebook. Okay.
Okay.
The first example that I'm giving you is okay, let's check up the periodic table.
I have to do what? Electronic configuration?
You'll have to first write down the electronic configuration of all of these elements. Okay, as I've did in all these. If you want, I will just show you the pages that I have saved. You can just revise that from there, and then accordingly you can work out some of the formula that I'm going to give you over here. Okay, so I'm just going to give you 3 examples from here. You'll have
Yeah.
to first work out the electronic configurations from the periodic table. Then you'll have to see what will be its valence electrons, what will be its valency, and then whether you'll have to decide whether it is going to form an ionic compound or it is going to form a covalent
Covalent compound.
compound. Okay, the second example that I'm going to give over here. Just write the list of these 3 compounds in your notebook. If you want, I'll show you the previous pages what I have saved. You copied the 3?
Yeah.
Okay. You can use your mouse if you want to go to the next page. You will
Oh.
be able to use it from your laptop.
No, because I'm seeing your screen.
Yeah.
So.
You will be able to control my screen. If you want to go to next page, just scroll, use your mouse. You will be able to do that.
Oh, okay.
Okay, so whichever pages you want to refer, you can just refer to those pages.
Yeah. So, sir, lithium is 7. So the
1 minute. I'll just give you the periodic table. Just look at the periodic table here.
okay.
First thing, what you will have to get about lithium? What is the first thing that you'll have to get?
The atomic number.
What is the atomic number of lithium?
7.
No, that's atomic mass number.
Oh, okay. Yeah.
Okay.
Yeah.
Right. So the first thing that you are getting about lithium, sorry, this is 3 and this
Eight.
is 8.
2 1 2 6
Valence electrons.
1 6. They need 7 more.
No. In this case, what is going to happen? It will just give away this one electron. So then
But
this is going to
it,
become the last shell. Nobody will be able to give 7 electrons to somebody. Rather than it will be more easier to just get rid of this last electron which is
then
there in
sir,
this
this
orbit.
still won't be full.
It will be full because then this orbit will not remain only. This is going to become the first and the last orbit. Got it?
No, sir, but
Because,
oxygen will not be full.
so
Sorry?
you'll have to work it out, no? How much is the valency?
Yeah. Okay.
You will have to work out what is the valency. Accordingly, then you will have to decide how many atoms are going to get the formula first.
To find, no.
Just get me the valencies of both of these.
Okay. Um, this is
For lithium, what it is going to do, it is going to give
give
away
away.
this one electron.
Yeah, so it's 1
Its valency will be
1. And it's gonna take, this is gonna take, so it's gonna be -1.
-2.
Minus,
Why? Because it
because
is
it,
needing 2 more electrons.
yes, but it's getting only 1.
No. So we'll have to work out the formula, no? First, we are going to work out the formula and then we will see how it is going to happen.
Okay.
Correct? So for lithium, valency is 1. For oxygen, valency is 2. And then what am I supposed to do? I'll bring this 2 over here. I'll bring this 1 over here. The formula of lithium oxide is going to become Li2O. It means there will be 2 different lithium atoms. They are going to give one electron to a single oxygen atom. You got that? Okay. Because here the valency we have worked out. Here valency of lithium is 1 because it is getting rid of 1 electron. Oxygen needs 2 more electrons. So its valency, if it is accepting electrons, is going to be -2. So just write down the valencies over here on the top. Just exchange the valencies and work out the formula of lithium oxide. So there are 2 lithium atoms and there is 1 oxygen atom. Now appropriately you will have to draw the diagram then. Okay. 1 oxygen atom will be here in the center with 6 of its electrons. And there are 2 lithium atoms on the side. When these
Oh, right.
combine,
You can use 2 lithium atoms.
okay, so this 1 electron will come over here.
Yeah.
This 1 electron will come over here.
Yeah.
So oxygen will get 8 of its electron, that is octet state. And lithium
Yeah.
will be remaining with these 2 electrons in the last orbit because when this 1 electron is gone, that orbit is
It's the
gone.
full.
Okay. Just draw on the, okay, I'll have to go to the next page. You can draw after combination what is going to happen. After they combine, how are you going to draw this structure?
Yeah.
Okay. After those 2 electrons are lost, 6 electrons of oxygen are there originally. These 2 electrons have come from lithium. This whole thing, because here
Is
there are 2
minus.
extra electrons, this will be 2 minus.
Can't
Similarly,
you write -2, sir?
minus 2 also can be written. Even this minus 2 is also fine. Okay. But generally in chemistry, when we are writing, we are going to write it this way. When we write valency, we write -2. But when we are writing the charge on this particular ion, okay, this is going to be known as oxide ion. We are going to write it, represent it this way. I can show the other 2 remaining lithium atoms. This is going to carry a single positive charge, +1 or 1 plus.
Hmm. 1 plus.
1 plus or +1, it's fine. Even -2 is also fine. This is oxide ion, and these are this whole thing will be lithium oxide molecule. Okay,
1 molecule.
1 molecule of lithium oxide it is, and its formula is going to be Li2. Got it?
Yes.
Second example. Which is the second example? You have written the 3 names of compounds whose examples you are supposed to work them out.
Yeah.
Second example is that of methane, that is a compound of carbon and hydrogen.
Hydrogen.
Have you written
So,
this much?
yeah, I have.
Hmm.
So, well, this needs 2, and
What needs
hydrogen
to?
needs carbon.
What is the electronic configuration?
Sorry, it needs 4. 2, 4.
Correct. Its electronic configuration is
And this
2, 4.
needs
Valence
1.
electron will be 4, so valency will be 4.
4. It needs 2. 1 more. Yeah.
So now we'll have to work out the formula of compound that is produced between carbon and hydrogen. Here the valency is 4, here the valency is 1.
Yeah.
What is the formula?
So CH4.
This is the formula of
Methane.
methane.
They use 4 hydrogen molecules and 1
Atoms. 4 hydrogen
atoms,
atoms.
atoms and 1 carbon atom to make 1 molecule of
Correct?
methane.
So what I
Yes.
am going to do? I am going to draw the carbon atom here in the middle with 4 of its electrons. And then
Yeah.
I'm going to draw,
It's a share, it's a covalent bond.
correct, because nobody can give or take electrons over here. I'm going to show this with the help of a cross. After all of these combine, just show the shared part. Just draw it in your book. Afterwards, I'm going to give you some more examples which will be as your home assignment, that is your homework. Okay, which when I come, I'll be able to check that. One second.
Done.
Okay. Okay, let it be. You have done?
Yeah, I'm done.
Okay. That's it. You can just compare. Got it? This is the molecule of methane, that is CH4. Okay.
Yeah.
Which is the next one that we are doing? The third one.
Magnesium chloride. Done, sir.
What is the atomic number of magnesium
12,
and chlorine?
17.
Okay. This one.
No, I don't know what to do. So
All right.
I know the
What will be the electronic configuration?
um two two 8 2.
Okay. Chlorine.
2 8 7.
Valence electrons.
They need to give away 2. So that's, yeah,
Yeah,
and
valence
they need
electron first we
to,
are writing. Only the number of electrons that are there in the outermost shell. Now we will write the
okay,
valency.
2
Okay.
1.
What is going to happen in this case?
2 chlorine atoms and 1 magnesium atom.
Correct? Because here, what will be happening here? Will there be sharing of electrons or transfer of electrons?
Sharing.
Sharing.
No, transfer.
Correct? Because chlorine will be accepting one electron from magnesium, but
Hmm.
there will be two chlorine atoms.
So that's
Which,
why,
so therefore, here the valency will be +2 and here the valency will be -1 because it is going to accept one electron.
yeah.
So one magnesium atom is going to give two electrons to two separate or two different chlorine atoms.
Yes.
Correct?
That's MgC2.
We'll have to work out also the formula. Magnesium valency is 2, chlorine valency is 1,
Hmm.
1 over here, 2 over here.
Yeah.
Formula of magnesium chloride is MgCl2. Okay, now I can draw the structures. First, initially, you'll have to show the atoms. Okay, there is one atom of magnesium. Have you drawn that?
Yeah.
Okay,
Yeah.
got it. How am I going to show this? You'll have to show these arrows.
Yeah. Going.
The electrons are that are getting transferred,
Hmm.
and then Mg. Same way I'm going to show on the other side. What charges I'm going to represent over here?
You're going to represent minus or
On
plus
what?
and minus.
Okay. On what I'm
Plus
going to
2 and -1 minus
write?
1.
Magnesium is losing two electrons, so that will be +2. And this will be minus and this will be minus. This is going to be, okay, a molecule of magnesium chloride. Okay.
वो अटका है, आप कर सकते हो. Okay, sir.
Okay. So we will just decide and fix up about the other class later.
Yeah, we'll do that. I can talk to my mom and then we'll decide.
Okay. All right. Yeah.
Yeah,
Right.
thank you, sir.
Yeah.
How do we exit this? Yeah.
You just if I just do this like this.